So today, relation between current and drift velocity அப்படிங்கிற கான்செப்ட் from current electricity, class 12 physics. So we have to understand the relation between the current and drift velocity by which the electrons are moving. For that, we are going to consider a conductor here. This is a conductor, metallic conductor. There are more number of free electrons available, and we know that in the previous class, in the previous video, we have discussed about the drift velocity by which the electrons are moving, and this is the drift velocity of the electrons. This direction represents the way in which the electrons are moving, or they are drifted from one end to another end, and this is the direction of current flow. And here we are having a conductor of length L, and these dots represents the electrons. Okay, free electrons. Actually they are free electrons which are responsible for conduction. Now let this be the last electron and let this be the first electron. So as a whole, the set of electrons are moving away from the negative terminal side to the positive terminal side. So as a bunch they move, as a bunch, as a whole they are moving, and the time taken for this electron to reach this end, let it be t, let t be the time taken. So the time taken to travel from one end to another end is represented by t, and this time taken is given by the basic formula distance traveled by velocity. That is, the total distance traveled from here to here is given as the total length of the conductor, that is L, and we know that they are drifted with the velocity, drift velocity. So the velocity is drift velocity, and we know there are so many electrons. So for that we have to consider the number of electrons present in unit volume of the conductor. So what is the total number of electrons present in one volume? And let it be n. The total number of electrons throughout the conductor. If you want to calculate the total number of electrons throughout the conductor, we have to consider the area of cross section of the conductor. Let area of cross section of the conductor be A, and the total length of the conductor is given as capital L, and therefore the volume of the conductor can be represented by multiplying this area with the total length. So A into L gives you the volume of the conductor. And the total number of electrons, if there are n number of electrons in unit volume, so in the total throughout the conductor, the total number of electrons will be n multiplied with this volume of the conductor. So we get NaL. Also we have studied about the charge. The charge is represented by Q is equal to Ne. This is a quantization formula, and here if you represent the charge per unit volume, we have to go for Q is equal to Ne. And if you want to calculate the charge throughout the conductor, you have to go for the total number throughout the conductor. So the total number throughout the conductor is NaL. Here we have to use NaL, and it is multiplied with the negative sign of the electron. So minus NaL into E. And also this equation is defined in the previous class. That is, the current is nothing but the rate of flow of charges, that is Q by T. Q is equal to minus NaL into E. So this equation represents Q, substituting the value here, and T is equal to L by V suffix T. This is drift velocity, and that is equal to L cancels, and therefore minus NaE, and drift velocity is given here. So the relation between them is I is equal to NeAV D, that is the drift velocity. That is, N is the number of electrons, and E is the charge of the electron, and A is the area of cross section of the conductor, and drift velocity is directly proportional to the current, because these three terms N, E, A are constant. They cannot change. So the total current is proportional to the drift velocity. This is the relation between the current and drift velocity. So again we are going to discuss about the current density and the microscopic model of Ohm's law in the next video. Thank you.